I recently made my first QSO or contact using the QRP Pixie, and I was really pleased because I've been trying to do this for a long time. The QRP Pixie is a tiny transceiver with just 2 transistors, and one transistor acts as an oscillator and is on all the time, and the second transmitter acts as an amplifier on transmit and as a mixer on receive. In its basic form, it just has one fixed crystal frequency, and that can be varied, or rather the receiver offset can be varied by using this potentiometer. But what does that mean in practice? Well, as I said, on transmit, the amplifier simply amplifies the frequency, which may be something like 7010. But on receive, the second transistor, the mixer, is combining the incoming signal from the antenna with the oscillator signal, and we're going to listen to the difference. So that needs to be a comfortable tone, say between 400 Hz and 1 kHz. When I made my first contact with the QRP Pixie, somebody in England called me back while I was calling CQ, and I nearly missed him because the pitch of his signal was so high. So it's clear that I needed to adjust the potentiometer, and it would be interesting to know and to check just what happens to the transmit and receive frequencies when you do adjust this potentiometer. It would give me a better idea of what's going on and also improve my chances of making contacts, I hope. Also, I'm curious to know just how much power this Pixie can transmit. I know it's very small, but I'd like to have some idea. So let's do some tests. I have everything ready to test, and the first thing I've done is connect the QRP Pixie to some regulated power. This is a regulated 12-volt supply. I've attached a little amplifier to the audio output so we can hear it without headphones, and I've attached the RF output, which would normally go to an antenna, to a frequency counter. And I haven't worried about adding a load to it. I'm not going to transmit, so it's not going to burn anything out. We're just listening to the receive. And I've also added my FT817 and got that tuned to 7010. This is a 7010 crystal, and I'm just pretending that this is another station calling me. And if I push the key, we can hear the tone of that, the side tone of about 700 Hz, and that's transmitting a very low power to this dummy load, which I hope will be picked up by the Pixie. So let's turn on the Pixie and see what we have on screen. Okay, so we've got plenty of sound coming out the receiver, a mysterious number on the frequency counter, and if I call myself, well, we can hear that the Pixie's generating a much higher tone than the FT817. And the reason is these numbers here. It's picking up the receive oscillator, and if I'm receiving a signal on 7010, I want to see something close to that on here, and it's actually 7013. So that's 3 kilohertz or 3,000 cycles above the sound coming in. And that makes a very high note. If you're on the piano, that's a couple of octaves above middle C. So to get that differential, we need to change the frequency of the oscillator. So if I put the screwdriver into the potentiometer and I key it, and now I turn the potentiometer, that's an octave above, and we need to see that 0. Exactly the same. So now we have the sound roughly the same. So it's 1069 something, so it's approximately 700 Hz, which is the same as the tone generated by the FT17 to make a comfortable sound to listen to that to. So it seems that that's tuned the receiver correctly now, so if somebody calls me, I'm going to hear a comfortable tone. So that's the frequency adjusted, and now it would be interesting to see what happens when we measure the transmit frequency on the Pixie and see if that changes when I move the potentiometer. So first of all, I'm going to put the potentiometer back to the halfway point and swap the dummy load over. So here we go. Okay, I've swapped the dummy load to the Pixie, and now if I transmit, this number should change from the receive oscillator differential to the transmit frequency. Let's have a look. So there it is, and it is 7010 plus 267. So it's very, very close to the 7010 crystal frequency. Now I have that adjusted or started at the minimum level. So now if I just turn that up, does it change? Very slightly. I've taken that all the way up. It's just about 100 hertz. So if that was adjusted for receive, let's just adjust it back to where it was for receive. Roughly right, 707 something. Yeah, transmit has hardly changed, and we could just leave it like that. So it will transmit at that frequency. Somebody will lock onto that, call me back, and I will hear a comfortable tone around 7 hertz. I'm now ready to test the power output of my QRP Pixie. So what I've done this time is again connect it to the 12 volt regulated supply. It's a 7010 crystal. The output transistor is a 2N2222A in a plastic capsule, and it's attached to a 50 ohm dummy load and to an oscilloscope. So what I'm going to do now is press the transmit key, and we can see the output. We can already see a signal because it's just faintly picking up the oscillator in receive mode. And what I want to do is measure the voltage, and that says about 14.3 or 14.4 volt. The way I'm going to work out the power from this is to use a formula suggested by Hans of QRP Labs fame in one of his very interesting articles, which I highly recommend, about RF power, which you can find on his website. And that's to simplify the mathematical process by taking the peak-to-peak voltage of a sine wave, squaring it, that's multiplying it by itself, and then dividing by 400. So if I times 14.4 by 14.4 and then divide it by 400, I get 0.5184. So that's about half a watt, 518 milliwatts, which is a very respectable output for a QRP transmitter and should enable me to make some contacts. And as ever with these figures, they are only approximate, but it's enough for me to know it's around about half a watt. And as I mentioned, the transistor is the 2N222A, and when I made my first contact, I only had less than 100 milliwatts because I'd put the wrong transistor in, a 2N3904. And so it was astonishing really that I made a contact about 100 miles, I think, or more, maybe 200 miles across the UK to Cambridge, or Huntingdon near Cambridge. So that was a remarkable thing. But now I'm very happy with half a watt. So I've finished setting up my Pixie, and what I'm going to do is leave the potentiometer where it's set. And then I know that when I'm using it, I'm giving out about half a watt, which is fine for QRPP operation. And that when somebody calls me back, or when I'm listening to other stations, they'll be at an audio tone of about 700 hertz, which is what I'm familiar with from using other radios. So that'll be easy to hear. And since I started this a couple of months ago, made my first contact and experimented a bit, I've made lots more now, and I've had contacts all over the UK and indeed several places in Europe. So I think I've even got to 1,000 kilometers. So I'm very excited about that. And I find QRP operation, low power operation, very exciting and one of the most enjoyable aspects of amateur radio. So I hope you found this helpful, especially if you're a Pixie user or thinking of making one and using one. They're very easy to build and very easy to set up. You can, of course, make lots of modifications, increase the power, make the frequency a bit more variable and so on. But just using it in its basic form and perhaps swapping a crystal now and then is great fun and very satisfying when you make a contact. So thanks for watching, and I'll be back soon with more videos about electronics, amateur radio and so on. See you then.